Okay, this is what we did last time. We created the class vehicle, and in this vehicle we have these three instance variables. In these three instance variables we have one of them that is primitive data type. Both of the others are class data types, but this class person is another class. And now I just would like to now explain the two types of relationships that we have in this class here. Now we have this vehicle that uses another class person. Now we have, let's say, if I represent this to be, let me just use some space. Let's say that this is the class vehicle. Now this vehicle is using another class, which is the class person. But then this vehicle is the superclass of truck, because truck inherits from vehicle, actually. So that means this vehicle is a superclass of another class, which is the truck. Now my point here is that this is inheritance, but this is just a class that uses another class. Now there's a way to distinguish between these two relationships. Now all these are different connections between two classes. This inheritance thing is a type of relationship when I say it's a is a relationship. The other one is the has a relationship. What I mean with that, this means a truck is a vehicle, right? A truck, when it inherits from a vehicle, a truck is a vehicle, but it's a special vehicle because it has all what the vehicle has plus some special things. So that's the type of is a vehicle. So if I have, for example, you have animal base class, a subclass would be a cat or a dog. A dog is an animal, a cat is an animal. So these are the type of relationship that explain inheritance, and it is represented with this kind of empty arrow. But this other one has a, like a vehicle has a person inside of it. Well, as an owner, a vehicle has a person as an owner of that vehicle. That's what this means. A vehicle has a string as the manufacturer's name. So this has it's a different type of connection between two classes, as the is a different type of connection between the classes. And that's how you can just explain that. This another way to represent or to explain these relationships between different classes. So is something related to inheritance, and when I'm using a class inside of another class, it's like a class has another class, so it's like it has or something. It's close to, it doesn't apply always, but it's the same idea. So now we used different type of classes. A class that is the vehicle is a superclass of the truck, and the truck is the subclass of the vehicle. We said that there's another word. The vehicle is the parent. Sorry, let me just be here. So this vehicle is the superclass. We said this is one way to represent it. Superclass, subclass. And you know what? Let me just try to open. I think I can't we? That's what we said. Like, for example, if you have something like this, it can be the parent and the child. The one on the top is the parent of and the other one is the child, which means now the vehicle is the parent and the child is the truck. Or the vehicle is the superclass and the subclass is the truck, or the base class is the vehicle and the subclass is a truck. There's different words. There's a fourth one that I just forgot to mention. The ancestor and the other one is descendant. So anyway, there's a lot of different kind of descendant. I think this is, anyway, it's not easy to descendant. Is it an A or an E? I don't remember. Descendant, maybe. I'm not sure about the spelling, but all these represent the exact same thing. The superclass or the base class are all different type of exactly the same thing. Ancestor, parent, all the same idea. And then we have descendant, child, subclass, derived. All these are the same thing. So you're going to see that sometimes in the book or in the website or some exercises they're going to mention this type of words. You need to be able to understand which one is which. But they're not really that complicated because they're self-explanatory. The parent is the one on the top and the child is basically below it, and then the ancestor maybe is someone who's older and descendants down. So they're all easy to get. Maybe the base and derived, this is maybe that you have to pay attention to. So that's the type of thing that I wanted to share. Okay, let me just put everything in one place. It will be easier to share in one place. All right. So we've been working with these classes, but among these classes we saw one very interesting method, which is the equals. Now the equals is that in the vehicle we just immediately use another vehicle because we would like to compare two vehicles, this one with another one. That's why we compare this manufacturer's name with the other that is going to be given as an argument. That's why you compare these two. That's what we used to do. Now when we're doing these things, what we mean is that when we are here, let me create a vehicle, a new vehicle, and let's say well, I need to create a vehicle. Let's put this is manufacturer 1, M1, 1 owner is a new person, and then you see I can just put just the one with no arguments, and let's call this V1 actually, because I would like to compare it with another V2. Let's say I have this V1, this is V2, and this is 2 with 2 cylinders, and the person I can just give it a name. Now by creating this creates a new person with this name. Yes?
So what if we did not put Muhammad?
It will be the same as this one.
Java, the NetBeans will give it different default?
What do you mean by default? No, because you were not here yesterday. And you were? Oh, because maybe then you forgot. Someone was not here yesterday. Okay, so the thing is that when I call this constructor, I call the one with no argument constructor, and I have something that is done inside this no argument constructor. So for example, now this is going to be empty, and this one is going to be Muhammad, the one that I gave, because when I use this one with the string, it's just going to take that string and put it inside. Yeah. Now the point is not here. The point is this. Now if I use if, I would like to compare these two. I use v1 dot, and I would like to see equals. But check that. I have two equals now. And this is confusing. Which one should I use? Well, obviously the second one is the one that is appropriate because I'm inside vehicle. I'm having an object, V1 is an object of vehicle, so I'd like to compare with another vehicle. It doesn't make sense to compare with something else. I compare a vehicle with another vehicle. But why do I have two of these? Why do I have to have two equals? Now, when we inherit from a class, we inherit everything that this class has, and also inherit everything that was inherited from that class. Now, this vehicle, does it inherit from anything? Well, no. What's the superclass of vehicle then? Exactly. So, every class that does not explicitly, like this, extends, it's like not a subclass of something, it is a subclass of object, the class object.
All class is the subclass for object.
Any class is going to be a subclass of object. Now, truck, is it also a subclass of object? Well, yes, because when I have which one? When I have this vehicle that is the superclass of truck, but we said that vehicle inherits, and where is it? Brush is going to inherit from object, which means now every truck is also inheriting everything that object has.
What does object have?
What does object have? That's a good question. Let's just go here and see. To get the object, let me just have objects and then click on it. This is what object has. Clone, equals, finalize, get class, hash code, notify, the things that we used to see before. When I use the dots, when I created the class, and then let's say, hold on, let me just give you a better idea. By creating a new class, then I'm going to call it test. Now this class, test, has nothing inside of it. But if I come here and say test, t equal new test, first of all, I don't have a constructor, so Java is going to give me the default no argument constructor here. So that's why I can do this. But now t dot should be empty, but it isn't. It has what? Well, all these ones that we're seeing here, equals, get class, notify, blah blah blah, etc. They're all coming from object. Of course, the non-private ones, because the private ones are represented with this icon there. If I double click here, oh, this is not private, this is protected. That's another thing we're going to be talking about, inshallah. But I'm talking about, let's say, this one is the private. The one with the icon here, it shows like something like a lock. It's not really clear, but it is like some kind of a lock. And this is the private thing. So all non-privates are going to be available here. And one of them is equals, that takes an object as an argument. So that's why when we do v1 dot, I'm going to see the ones in bold, that these are the ones that are inside the class vehicle. The ones that are not bold, these are the ones that are coming from the superclass or one of the superclasses. Let me see something even better when I do use a truck. Truck t equal new truck. Now the new truck is going to have this manufacturer and then number of cylinders, whatever, and then the owner, and it's a new person. I'm just going to make it like that. And then the last two is the capacity, whatever, and then I'm just putting any number. Now I just would like to show that when I use t dot, now I'm going to have, again, check this, equals the one object. This one comes from object, the superclass of the superclass. And I have the equals inside the truck. It's bold, that means it's inside the truck. And I have another equals that comes from the vehicle. And you can see I'm inheriting up all my ancestors, all my parents. Like this truck has vehicle as a superclass, and superclass of vehicle is object. So I'm getting everything from the top until inside this class truck.
So
Yes.
Can I compare equals? has 5. Name, number of cylinders, but vehicle has only 3.
Yes. You're talking about instance variables
Yes.
that it has access to?
Yes.
Yes.
Vehicle has only 3.
Yes.
Object has none.
Yeah.
Then what's the point? If I'm comparing equals, it should be inside. Vehicle inside.
So now the thing is, your question is, if I'm in the truck, not in the trunk. I'm going to delete this test because I don't need it. I don't want to get confused by it. So the truck here, when I'm using the equals, I'm comparing the equals from the truck.
We can borrow one TC from here, right?
Yeah, sure. So if we get this truck, that this is the other now, I'm going to compare a truck. So the vehicle is going to be available from the truck.
Yes.
So there's no real need to use the vehicle here, the equals from the vehicle.
Yes.
Now my point that I'm trying to show you is that, why do I have all these equals like this? I have all these equals like that because each class has a different equals with a different signature. And different information. But check the toString, for example. toString also comes from the object. And I have a toString in the object, a toString in the vehicle, and a toString in the truck. But I'm seeing only one toString. Why?
Does it make change?
No, it does. But the toString of the vehicle it has the same signature as the one in the object, and the one in the truck has the same signature as the one on the vehicle. So when they have exactly the same signature, now when I use toString inside the truck, I'm going to execute the one inside the truck, and the other one is not visible anymore. I changed the toString. That's the overriding thing that Java gives you here, so that NetBeans shows you here, so you can see that this. Now toString exists in my superclass, but I changed it in my class. I changed the behavior of a method, so I have only the same name, but the work is going to be different because in my class toString should do this. In the vehicle, the toString should do something else. In the object, it will do something else. So depending on what I'm using, which object is going to be calling the toString. Now if I use this t.toString, I'm going not to use the toString from the object because I changed it
Change twice.
twice. Exactly. Yes.
So overriding is like take something that exists, but change it to specific into one.
Exactly. Overriding now, what it means, I'm inheriting everything from my superclass, but I have the ability to change the behavior of what I'm inheriting. Of course, I change it in my class. I cannot change the one in the class that I'm inheriting from. For example, if I change toString in truck, it does not mean that now toString in the object will not work. No, it will work, because if I create an object, the toString from object will still work. But I'm talking about now in the class that I'm in. If I override whatever I'm inheriting, I'm able to change the way it works with one condition. It has to be exactly the same signature of what I'm inheriting. If the signature is different, it's not overriding. I'm not changing the behavior. I'm just creating another version, like I'm overloading. You remember overloading? Many methods with the same name but different signature. And that's what I end up having here. If I do something like t dot and I see the equals, now I have three types of equals that I can use. I can use the equals with an object, another one with the truck, and the other one with the vehicle. This is like overloading. But overriding means it's the same name and also same signature from something that I'm inheriting. I inherit something and I change it inside of my class. And we've been doing overriding since Java 1 because toString we always overrided it. Because we always just changed the behavior of toString. We never had to change the data type, but for the equals, like here, we used the data type of the class we were in. So we were not doing overriding for this equals in the past, but now this is going to change because we don't want to have these conflicting thing. Why would I need to choose one of these? I will just make one of them to be less confusing, and then I will make sure that I'm going to compare vehicle in a vehicle, a truck in a truck, and things like that. Yes, your question?
I can override the equals, right?
You can, yes, override. Whatever you inherit, you can override it. All you inherit, you get the benefits from it, but if you don't like the way it works, you can change it by overriding it. Creating a method with the same name and same signature inside your class, and this is what overriding is. Being able to change the behavior of something that you inherited. Yes.
Override it means same name and same signature.
Yes.
Is it complex because three class have two string?
What kind of complexity?
How can I print the first class?
Now, if you're in the, let's say, in the truck, now the two string that you're going to use is the one from the truck. Do you need the one from the?
If you change the truck to vehicle,
It will be the one from the vehicle. So it's not complex. It gives you like more options actually.
So now here. Which override it will take? Just
The one,
which override? Just
the T belongs to which? Is an object of what? Of truck. So it's going to use the one from the truck. Yes. Yes.
So why not overriding equals?
That's what we're going to do, but it's more complex. That's what I'm just trying to tell you, that it's more complex because of, like, check, this is vehicle. Equals in a vehicle like this. Now if I'd like to override the equals, now I just would like to put this into comment so you can see what needs to be done when I'm overriding. What needs to be done is this one. Okay, I need to compare all these three to be exactly the same. I don't care about the hash code. I'm just going to remove it just to avoid this unnecessary attention. Now check this. This thing here
Simple code.
is the same as what we have here. Yeah. But I have to do some other things before I can reach here. And that's what I'd like to talk about today. This extra thing.
how you write override? Is it same object?
What do you mean?
Why you write override?
This one here? Because now I'm overriding the equals. Because it's the same signature than the one that I'm inheriting from the object. While here it was not the same signature, so it's not overriding here. This was just another method. It's like some kind of an overloading on different levels. But here, now it becomes overriding because I'm changing the equals that I'm inheriting from the object, and I would like to now do something. Now what does this do? These are all things that I need to check just to make sure that I'm doing the verification. But I'd like you to understand those things, and I will get into that, but not with the vehicle because it has a lot of different type of things. I'd like to start with the simplest one, which is the person. Because the person, we have only one instance variable. It will be easier for us to understand just a shorter equals. But so far you get the difference now between overloading and overriding.
Is overloading bad?
No, of course it's not bad, but it's the equals might be confusing. Because now if I have a truck that inherits from, that is a superclass of another class, and you design another equals that is not overriding, you're going to be having like 4 equals, or maybe 5 and 6, depending on how far down you go. And this might be confusing for the user of your class, which is, okay, why would I have 4? Which one should I use? It's better to have only one that is going to deal with whatever you have. That's better. It's less confusing for the user of your class. And it's better programming. So that's what we're going to be doing. But it's not wrong, it works. Now if I'm comparing with the equals, if I'm not getting confused, that's fine. But we don't want to do that.
Doctor,
Yes.
overloading is like constructor.
Overloading,
It's like constructor same class but different, same name of the class but different signature.
overloadings, Same name as the class, but different. But it's the definition of constructor is not the same name of the class and different constructor. Well, it's different. What is the definition of a constructor? Is that it's a method. It's a special method because it's a method that do not have any return type, and it has the same name as the class.
And that's different.
And it can be overloaded because it's a method. It can be overloaded. Now, what is overloading? Many methods with the same name and different signature.
Same constructor.
So no,
Constructor they not have data type.
but a method does. Overloading does have a data type, return type. But the signature is not part of the return type, but it has a return type. And the return type is something that is also something we're going to be talking about later with this inheritance and overloading, overriding. But it's another discussion. But for now, I'm not sure to say. It's not going to be very. I'm not going to be very specific and precise if I say that overloading is like constructor. No, because a constructor can be overloaded. I can have many constructors with different signatures, which means it's many methods with the same name but different signature. So this is overloading. The constructor is overloaded, but we have this like this one, system.out.println. Do I have that? Okay. Now this print line, for example, as you can see here, I have many of these print line with different signatures, many methods. Again, I'm not looking at the return type. I'm just looking at many methods with the same name but different signature. But does it make them like constructors? No. So that's why I don't. It's not accurate to say that it's like constructor. But it can be overloaded. A constructor can be overloaded because a constructor is a special method. Why special? Because it does not have a return type. I don't have any void or non-void thing on a constructor, while a method needs to have something void or non-void. Is that okay? Yes.
Question before we go on.
Yes.
Can you open the page?
Which one?
The page.
Yes. This one or this one?
No. For that one now, the truck and the person,
Yes.
both of them is a subclass from the bike.
No, because a person is not a subclass of vehicle.
It's a class in vehicle.
It's a class used by vehicle. Because vehicle is using two classes basically, string and person. So it's not the same relationship between person and vehicle and truck and vehicle.
Okay, for that vehicle and same programming, we write private for the person.
I didn't get that.
Programming,
Yes.
we write a private class for the person.
Private class for the person. Okay, yes, yes.
So how can we take the information from the person from another class?
Well, we can take only what's public from the person. Right? We cannot take whatever is private. For example, now let's see this person here. The person has private name. So if I go into the vehicle and I'm using this, you see this owner is a person, right? Now if I do this owner, now this owner, this is the one from this is the one that is highlighted. If I do the dot, I'm not going to see the private variables or private methods if there are any. I only have access to whatever is public, non-private, let's say, and that can have access to.
For that one, truck can take only the information of owner.
Truck,
Because it's
I'm in the truck. I can only take information from.
for the owner, from the bike.
I'm not sure to understand what you mean with that.
Now, truck doesn't have any relationship with person.
It does. It uses a person as well. Because truck inherits from vehicle,
Yeah, that's my question.
it's indirectly using person.
Like the same information, vehicle.
Exactly. Whatever is available in vehicle is also going to be available. No extra thing. Yes. Yes. So let's go back to this person and try to understand the equals. What needs to be done when we would like to override these equals? Now, by putting this as an object, there's something that is going to be weird. Because now by comparing two objects, I need to compare two persons. I don't need to compare an object with a person. So that's why, first of all, we need to understand one thing, is that if I declare a variable of one type, let's say person, for example, or let's start with vehicle, or person. Person b equal new person. Now if I do that, now this person, I can put it into an object. Like this is, let me do this. Because there's a rule that says if you inherit from a class, you can put this object from that class into the superclass. Why? Because we said that this class is from the superclass. When we say like the truck is a vehicle, a truck is a vehicle, that means I can put this T, I can put inside of it this new vehicle, or let's say new truck, with all this extra information that I can put in it. This is person P, whatever, and then -1, -2, whatever. I just put in some.
So what do you mean you can put?
That means I can do this action here. I can take this. This is a new truck, and I start in a variable v1. What is v1? It's a vehicle. I can also stuck this truck into this obj. What is obj? It's an object, and I'm not getting a mistake. It's not a mistake.
Inheritance is downward.
It is.
And upward.
But the benefits are you benefit from whatever is on top of you, on top of that class. So you get benefit. You inherit from everything that is above that class that it is inheriting from. So the inheritance goes down, but whatever is on the top can be used down. That's what I'm trying to use. When I'm using like this object is going to be the superclass of vehicle, which is the superclass of truck. In the truck, I'm using everything that object has, as well as everything that the vehicle has. I'm inheriting from everything.
I can do the opposite. T, new vehicle.
No, that's not something that is possible.
It's not possible.
Because, hold on, there's something about that we will talk about later. Because downcasting is sometimes possible. I mean, it will be possible sometimes, but it's very, very specific. Going down with these data types things is a different issue. But going up is what are we dealing with. For example, if I'm doing something like this, I'm just taking a person and store it inside of an object that is an object. And it's possible because I'm going up. Person is down, object is the superclass of person, so I can go up and put an object from something that is a base class to its superclass, or one of its superclasses. That's what I can do, and that's what I'd like to show you. That's why we can basically do this, because equals is from an object. I need to put anything inside of an object and then get it back as a person later on, but that's something else. I'm going to talk about it later. But the thing is, it's possible to have this relationship. Let me just take this and store it here. Hold on. Control V, move it right there, and save. So now, if I have, like, this is a variable. This is a variable. Let's say I'm going to represent that variable as this. Hold on, I'm just going to get confused. I don't want to get confused, so I'm just going to save this. Now I have this person P, which is an object. This is P, right? And this is obj. Now I represent them like this, like a cup. Well, it's a variable. I can put something in it. And this is obj. Okay. P is a type of person. The class is person. This is what I can put here. But this is the object is the class object. So in an object I can put anything that is object, but also anything that inherits from object. Everything that is down, I can put it there.
Also, what use? Vehicle uses person, I can use person.
But don't forget, no, the person itself, does it have a superclass?
Object.
So which means it's object. So I'm inheriting also from objects, from here.
All information in a vehicle, you can use it in a truck.
Yes, yes,
The opposite, is it right?
no. The opposite is not right. I can use everything from my superclass, but the subclass does not even know that but the superclass doesn't even know if there's a subclass or not, because it goes up. You inherit from what your parents has, not the other way around. Okay, so let me get this down. So now, in this, based on this example, I can put also inside of this person. But in Java, this is going to be remembered that I have an object, but inside of that, I don't have an object. I have something that is a person. So it remembers that there's a person inside. That's why what I can do when I do something like this. Now, if you look at the code here, let's forget some of the other things. I get, by comparing, I will do something. Let me remove these. I have person. I'd like to compare two persons, P1 and P2, and this other one is Muhammad. And if I'd like to compare with these two, I have put P1. Is it equals to P2? Now I'm going just to display equal and not equal. So if it's true, if this is true, it's going to be equal. If this is not true, it's going to be not equal. Now, if I run this code, what should I see?
Not equal.
Not equal, because this is not equal to this one. So that's what I'm going to see, inshallah. But notice now what I just did. P2 has been sent inside equals. P2 is what? Is a person. And equals takes what as an argument? Object, which is, I'm doing something like this. I'm like stored P2 inside this object over here. But it remembers that this P2 is a person. So it keeps that information. When I'm storing it, it remembers that it's the box, the cup is object, but I'm putting inside of that object a person. That is P2. And then this P2 now is going to be here. And I'm comparing some of the things, but then check this thing that I'm doing here. Forget about these, we're going to see that later. But I'm just doing some kind of verification, and then later on I do something like this. You remember the final? I can remove the final because it's not something, it's a useless distraction for now. I'm doing this. What does this do? This is
The new P.
no, this is what? When I put a data type between parentheses, that means I'm doing some typecasting. So I'm converting now this object to a person. because what I'm doing now, when I'm putting the person, I can put it here, no problems. But when I would like to extract now the person, because now if I'm here, you see this obj that I'm having here, obj dot does not give me anything from the person. It gives me whatever I have in the class object, even though what's inside is a person. But now because I'm looking at it as an object, so I have access to only the methods that are available in object. But if I'd like to have access to the name of this person, I need to first convert it to a person. That's why I declare a variable of the type person that I call other. And this other, I take the whatever what's in obj and then convert it to a person. And this other, now this other has everything that a person has. With this equals, of course, that it was also available, but also the get name, the set name, the toString, and also the others that are coming from my superclass.
So why convert object to string person?
Because I need to compare the name. And if I use obj dot, I don't have the name. So that's why I put it inside of an object, but then I'm converting it back to a person so I can compare the names. Now, I'm just going to do something that we know. This is dot equals, because now I'm comparing two strings, two texts. I'm comparing this one with the other one. So I'm comparing the one in this name with the other name. But I cannot get the other name unless I convert this to a person. If it was not a person, I cannot do that. If
return false, return true.
Well, yeah, this should return true. Yeah, because it was like this. If it was not equal. If it's not equal to this, then it returns false. I just would like to keep the same idea, or maybe just do something like this. I convert it to a person, and then I return. Is this equal? If this is equal, it return true. If it's not equal, it return false. But anyway, that's another issue. Because I wanted just to let me do something like this. Else return false. So I'm getting some code that is closer to what we used to do. That's what we used to do. So all these things, we don't care about them for now. But what we would like to do, basically, is this. When you give me an object, I would like to convert that object to a person so I can just check the names of what it has. But there's some other things that I would like to do, but this is something that does something more. But we just need to do some kind of checking later on. I will talk about that. But this is what basically I'm doing. I'm taking an object, I'm converting that object to a person, so I can just get the information from the person, and I'm going to return true or false later on.
There is different if you change the person to string, typecasting.
But how can you change a person to a string? You cannot convert. This will be a problem. You cannot convert. Like, say, for example, I have this person p1, right? Can I do something like this? String s equal string p1. How can you convert p1 that is a person to be converted to a string? It's not possible. But what I can do, I can take this object O, I put p1 inside of it, and then I take another person, p3, and I put inside of it something that I convert from person, from this O. Now this O here is okay to do that because I'm converting a person. Basically, I can do this too.
So why convert person?
But I cannot, if I convert this, is going to give me a problem. That's why now converting from a superclass to a subclass, this is what I'm doing, right? I'm converting a superclass, O is from object, that I'm converting from to person. I'm going down. This is called downcasting. Downcasting is dangerous because I need to know what I'm doing, because if I do something like this, Java is not going to tell me there's a problem.
So what's that correct?
But there's a problem. If I run this, let's see. You're going to see exception. String cannot be cast to person. You cannot convert string to person. But if I do something that makes sense, I won't be having any problem. So that's why going up is okay. This is going up. This is called upcasting. Why is it called upcasting? Because I'm going up from the person to the object. I'm putting a person to object. And this is going up in this hierarchy, like some representation like this. From person to object, it's going up, it's upcasting. Downcasting though, let me just close this. Downcasting is when I'm doing something like this. Downcasting means take something from
Object.
the object and convert it back to something from one of its subclasses. And this is dangerous. You need to know what you're doing. You cannot do that unless you have done an upcasting before. You cannot just do this downcasting like this. If I don't do this, well, it's going to, of course, oh, now it doesn't exist. But if I did not do this, it's just new object. Now I just created an object. I did not do upcasting now. I'm doing a downcasting without upcasting. That's a problem. So
We use upcasting and downcasting.
yes, but it has to be the same type, because I can put like something like this, new vehicle, and this is, yeah, let's keep it at 0. And this is upcasting, but the downcasting is not appropriate. I cannot convert like O now is an object that has a vehicle. You cannot convert to a person. So the downcasting is dangerous because you have to be careful. You have to make sure that actually it has the correct class. That is why.
When downcasting.
Just let me just finish this one. That is why here, if you remember, there's some checks here that I'm doing, and one of the checks is this one. This one, just make sure that I have the same class. I get the class that is inside. This get class, it means like this one. This gives you the class of this person. It gives you person, and I'm comparing this person. Do I have inside object? Do I have person? So if I don't have person, return false. Don't try to even reach this stage. This is going to return false. I'm not going to do the downcasting. This just make sure that I'm looking at what's inside of obj. Is it different from what this class is? If it's different, okay, it's false. It cannot be equal. It's not possible. If you put a vehicle, you compare it with the person, they're not equal because they're not the same class already. So I don't need to even check for the name or whatever. So this is a verification that checks that I can safely do this. Because if this is true, that means I can do downcasting. If this is false, that means whatever is inside obj is not a person. I cannot do this.
Get class from object.
Get class is available from object, yes.
Thanks. What's the meaning?
Get class, it just gives you what's the class of this of this one. This get class means this is person. This means like person. And this is going to check what is stored inside the obj. If it's another person, that means it's fine. If it's, for example, vehicle, that means it's not okay. I cannot go and do this. This is going to be dangerous now if I do this.
Upcasting.
Now I'm talking now this before this doing this thing. It's going to be okay to put the vehicle inside obj, but is it okay to convert this obj into person?
No.
once it's a vehicle? No. That's why this question that we ask here with the obs, this get class and thing, just make sure that I can safely do a downcasting. But let's not talk about dates for now. We'll talk about it later. Now, what I'd like you to focus on is just this. I put a person inside of an object because I'm doing upcasting, and this is okay because person inherits from object. And then I convert that person to a person so I can compare the name. And then I just do whatever I used to do before. I would like you now just to help me do the same to vehicle.
Can you go back?
Yes.
Object is object, superclass,
Yes.
and the person is subclass.
Yes.
Can you create change that
This is the downcasting. Yes.
downcast?
Yes. This is the downcasting because I can take whatever it's an object and convert it back to down a person. But this is dangerous, as I mentioned, because you need to make sure that before you do that you have the correct object inside. It's the correct type. Now I'd like to do the same here in this equals. Let me go and find the equals. Here it is. I'd like to convert this to, instead of being the vehicle, to being an object. So you see, as soon as I convert to object, it tells me, well, sorry, but manufacturer's name doesn't exist in an object. An object does not have this manufacturer name and number of cylinders and owner. I have these inside of a vehicle. So before doing that, what I should do,
This
I should convert to a vehicle.
other
Vehicle, well, I'm already using other, so
object.
let's,
Equals. Equal.
what you would like to name it. So either you rename this one, what is better to do is to rename this one to obj. So I can use this other, which will make it more easy to understand. Vehicle, other, equal, what should I put here?
Vehicle.
Vehicle, between parentheses, obj. This is going to convert this to an obj, and then this other, I will use it instead of the object, and this other is okay because it's a vehicle.
Downcasting, right?
And this is the downcasting. And this is how I convert the equals from being in some sort of overloading to an overriding. Now if I create a vehicle, V, now if I do V dot, I have only one equals. I don't have two. However, to be safe, that's because now what if I do something, like this, you see, if I put V here,
Downcast.
V is an object, but it tells me variable V might not have been initialized. Okay, let's initialize it.
So this is not neither downcast.
I'm just showing you a problem that is something that is not going to be detected. So I have to deal with it inside the equals. But now if I do something like this, can I compare P1
No.
with V?
I don't think so.
Well, but it shows me it's okay. If I run, I have an exception. Because now I'm trying to get this V and convert it to a person, which is not possible. The downcasting is always dangerous. You have to be very careful to do before you do that. But what I can do is to do something like this. By doing something like this is going to return false, and not even do the checking, this conversion, this downcasting is not going to happen, because the classes are different, so it will stop right there. So if I run now, it doesn't give me this exception because of this checking that I'm doing here. So basically this checking, I'm going to also do it here. So I'm just going to be safe when I'm converting down, when I'm comparing two vehicles, just to be sure that if someone gives me something other than a vehicle to compare to a vehicle, it's not going to be an exception. It's going to be a not equal message that I'm going to get. Yes? In the main?
Did it give you an error because you compared a vehicle which was an object
Yes,
person.
exactly.
The same.
Exactly, because that's a good point. Because when I'm doing here, when I'm doing something like this, I'm sending v inside an object. So I'm doing an upcasting, and then I'm going to try to do a downcasting. But if the downcasting is not done correctly, if I'm not checking the correct class is converted to, it's a problem. So that's why, yeah, it's a good point that this is doing an upcasting. But if I put this p2, I'm doing an upcasting with the person. So when I get inside, this is the classes are not different. So I'm not going to return false, and I'm continuing, and I can safely do a downcasting.
Doctor,
Yes.
you said before you do upcasting and downcasting, should write a get class to be safe, right?
The get class, this one. No, before doing the downcasting only. The upcasting is always safe.
Downcasting.
Downcasting is the problem. Upcasting is okay. You can always put an object from a subclass into one of the superclass types. But the downcasting is the one that can be dangerous, because you can put whatever you want. I can put something like this. This is downcasting from an object to an integer. But how can you convert a person to an int? It's not possible. It has to be compatible. Is that okay?
False. Because of
This is going to return false. This one over here. Yeah. It will not even reach this line over here.
now my downcasting is safe.
Yeah, exactly.
If you delete it, it become error.
It will delete it. It will become error if I'm not doing the upcasting correctly. If I'm doing this, it's not an error because I'm sending a person, so I can downcast to a person. Fine, no problem. But if you do something like v here, you're doing an upcasting with a vehicle, and you're trying to downcast it to a person. That's not a problem. That's a problem. That's not possible. All right, inshallah. So let's do it now for the truck. The truck is the same thing. I'm going to make it object. And okay, hold on. And I'm just going to leave it other because I'm going to downcast it later. I'm going to make this obj here. And then here, let's make the test. What is the test?
Condition.
Yes, the condition that we'd like to.
Get class.
If the get class, I can use this, so I just can do just the get class without the this because it's from this class. I just want to add the this just to make it clear that I'm comparing this one with another one. I'm comparing this one with,
It's not the same as
if it's different than the obj.get class, then I'm going to
return false.
return false. And then if I'm not returning false, I can safely now do a downcasting to a truck, which I'm going to call the other. Is going to be truck obj. And now I correctly did this overriding. Yes.
Do we need override?
Yeah, you see here, we don't need to put it. It will still work. But NetBeans tells you it's better to put it so you can know that this actually is overriding some method outside of. So you're changing something that you inherit. So it's clear that shows you that you're doing that, but it's optional. It's a yeah, exactly. Just to make sure that you know what you're doing. Yes.
This get class is it a truck? And,
Get class.
Yes.
Well, this gets class is truck, exactly. This one is always known, is the same class that I'm in.
And object.
This is based on what you give me between parentheses. Yes, as an argument. A lot of fun, right? So what I'd like you to do, convert these equals that you had to this, so you can use this object, so you can practice this equals that is overriding the equals, and then you can go for the next exercise.
What is the inside get class?
Get class.
Yes, just get class. Class.
If you would like to just go here and see what is inside, but it's just you see the definition of it's native. What is that native means? It's something that is not showing us the code. We don't have the code for that, because in the object this is not showing the code to check that they have the same class. So this is something that is programmed by the compiler to be able to deal with. I think a lot. I don't know exactly what this native means.
So the method, what's check?
It just gives you this get gives you or something. It gives you the name of the class. I tried to give you an example by just saying, okay, this is going to be truck, and it's going to compare this to whatever the other is given to me. What is going to be given to me as an argument? So if it's vehicle, for example, if someone gives me vehicle, so I see these are different, and yeah, but there's some catch about it. I'll try to change it with string, for example, it's much clearer, or person, it's much clearer, because there's a catch later on that I would like to talk about it, between if you're comparing things that are the same, not the same types, but that can be related to each other because of inheritance. And that's another story. That's another story. So let's leave it for now. Let's not complicate it all at once. Let's take it step by step. But if it's a completely different class, it's going to be something like this. Like this is a good example. Because there's something when they are related to each other. Is that okay so far? So we've seen upcasting, which is something that is okay to do all the time. Take whatever object from a subclass and put it into a type of a superclass. And then downcasting is something that is going to have to be done safely. First of all, you have to check that you can do it before you're doing it.
Why did not write a method get class with upcasting? If you use upcasting.
Upcasting is not a problem. So I don't need to check before I upcast.
You can't change it in
You can upcast, no problems. The downcasting is the one that is dangerous. All right, so I stop